Hello, class and fellow Math B Honors students. This is Mr. Kuo, and we are going to be doing our first lesson of the year, which is the 1.1a lesson on simplifying expressions. So the very first thing we have to do is we're going to have to define 4 vocabulary words. And let's go ahead and define them right now. So right here we have natural numbers, and natural numbers are the counting numbers, and it's basically the numbers that we can use our fingers to count with. So it starts from 1, it goes to 2, 3, and forward. 0 is not a natural number, and remember that natural numbers have to be kind of like whole numbers. So very, very similarly, whole numbers are the set of counting numbers that include 0. Okay, so it's really just one extra number in addition to um, the natural numbers, and they start from 0, 1, 2, 3, keeps going, and it really goes on to infinity. Integers are very similar to natural numbers and whole numbers, but they also include their negative counterparts. Okay, so integers are whole numbers, or you could also say natural numbers with their opposites, with their opposites, in addition to 0. Okay, so it really ranges from all the numbers on the number line that are whole. So it can go from like -3, -2, -1, 0, 1, 2, dot, dot, dot. And really there's a dot, dot, dot on the left side as well. Okay, and then finally, rational numbers. Okay, so this one is one of the definitions that you definitely want to remember. The word rational has the word ratio in it, and rational numbers are basically any number. The way I would describe it is any number that can be written as a ratio, written as a ratio or fraction. Okay, obviously decimals are rational, right? As long as they're terminating, right? Terminating decimals are considered rational. Terminating decimals are rational. Okay, so obviously any integer is rational, but also improper fractions are rational. Um, any decimal that doesn't have a repeating sign, which is considered a terminating decimal, is a rational number. And um, repeating decimals that have a line on top, if you look down on this is zero point 0.7 repeated. 0.7 repeated is technically 7/9, if you're familiar with that rule of the repeating bar over the digit. You'll know that that's considered rational as well because it is technically a fraction. The square root. Now, some square roots are irrational and some square roots are rational. In this case, the square root of 9 actually simplifies to 3. We're going to go over this later on in the year, the square roots of values. But the square root of 9 is technically 3. So we know that the square root of 9 is also rational. So very, very quickly, I'm going to go ahead and put all 8 of these numbers into the most specific category, right? Because obviously some of these numbers can fit into multiple definitions, but you want to go with the most specific category. So the rational numbers is going to have the most amount of numbers that are included. Integers are next, followed by whole numbers, and then finally natural numbers. Now, there also should be a little section that would be irrational, but all 8 of these numbers are included in these 4 terms. Okay, so the easiest would first to be classifying the fractions, because we know that the fractions are not integers or whole or natural. So 3/4 should go somewhere right here, right? 0.7 repeated would also go in here. 2.15 is also rational. 3.5, which technically is 3.5, is also rational, right? So I've taken care of all 4 of the rational numbers, and now I'm going to go ahead and classify -6. It's the only one that's negative, so I know that it's the integer of the group. The square root of 9 is actually 3, which can be a whole number, but again, you want to use the most specific, the most, I guess, simplified version of it. Natural is 3, or square root of 9, I should say, 8, and then 0 would be classified as a whole number. Okay, so this is just a real quick introduction to the 4 definitions, the 4 types of numbers that we have in our algebraic world. Explain in words how natural and whole numbers differ. Whole numbers include 0. Very simple. Whole numbers include all the natural numbers and include 0. So 0 is important. Explain in words how integers and rational numbers differ. Integers must be whole, right? Integers must be whole and cannot have a decimal or a fraction. Now, both of them can be negative, though, right? Integers can be negative, and whole numbers, rational numbers, I should say, rational numbers can be negative as well. Rational numbers can be fractions or decimals or repeating decimals that can be negative as well. So, rational numbers are often used to create linear expressions. A linear expression is a mathematical phrase consisting of numbers, variables, and arithmetic operations that describe a real life situation. Remember that an expression is just a combination of operations, numbers, and variables. We are introducing ourselves to the expression again, which we have talked about in Math A, 7th grade math. And today in this module, we're going to be simplifying expressions again, right? So we have to be very, very comfortable with how to add numbers, whether they be fractions or decimals, and how we also add like terms like the same variables, right? So something as simple as 3x minus 5 is obviously an expression, as well as, x plus 2x minus 9 plus 4. Now, you could argue that these two are the same exact expression because they simplify to the same simplified version, I would say, right? X plus 2x would give you 3x, and then -9 plus 4 would give you -5. So these are just 2 different examples of linear expressions. Okay? Let's move on. So in order to in order to simplify expressions, we have to be very, very comfortable with the order of operations. The acronym for the order of operations is PEMDAS, right? We remember it as please excuse my dear Aunt Sally, but really it's because it stands for parentheses, exponents, multiplication, division, and addition and subtraction. Now, usually you want to read your expression from left to right, and you follow the flow of what, you know, priority you see. So if you look at a linear expression and you see a parentheses, which symbolizes a group, you definitely should simplify that group first, okay? Followed by exponents. You have to square things or cube things if you see that. And then you then multiply, divide things, terms, whatever the case may be. And then finally, addition and subtraction is what we do last. Okay. Um, so number 6 is kind of like a riddle. Place parentheses in the expression 2 times 5 plus 4 divided by 3 so that the value of the expression is 6. So at this point in the video, if you want to pause, you can pause, but I'm going to go ahead and do this with live time. I have to place parentheses somewhere. I already know that if I didn't have parentheses, this would be 2 times 5, which is 10. So I already kind of have a guess that I should probably put the 5 plus 4 in parentheses first. And if I do that, I get 2 times 9 divided by 3. And you can see that that actually totally changes the original expression, right? The inclusion of a grouping makes me have to do 5 plus 4 first. So 2 times 9 is then going to be 18, which then divided by 3 simplifies to 6. Okay? So how comfortable are you with simplifying expressions? How comfortable are you with following the order of operations? Right now, go ahead and pause this video, or work quietly on 7, the entire page. Right, this is the perfect time for you to practice your skills, and remember that you always read left to right. And another thing you want to remember before I let you guys practice is this right here, 16 minus 10. You have to remember that this, although this looks like a minus sign, you also have to treat it as a negative sign. So if you remember from Math A or 7th grade, we know that we can rewrite this entire expression like this. 16 plus negative 10 times 2 plus 9. Okay? And I want you to train your brain to thinking that this is a negative sign, even though it looks like a minus sign, right? This sign is attached to this term. So this becomes negative 10. And then you obviously have to do multiplication first. If you did 16 plus negative 10 as your first step, that would be wrong because you're not following the order of operations. Okay? So just remember that multiplication and division always go before you add or subtract. So negative 10 times 2 is negative 20. And then I could write 16 plus negative 20 plus 9. Okay? And that gives me, well, 16 plus negative 20. You have to practice your skills of adding and subtracting negatives. 16 plus negative 20 is negative 4. Negative 4 plus 5 ends up being, oh, I'm sorry, negative 4 plus 9 ends up being 5 as my answer. Okay, always follow the order of operations, and obviously some of these questions will be a little bit more challenging, so make sure you check the lesson notes and check your answers. Okay, thank you.